Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say that I hope everyone is doing all right out there. Now, this is Unit 5, Lesson 7, I think, but I don't know. I'll put the correct title on the video. So let's go ahead and look at our goals, which is what's important, not that I don't know the lesson or not, but the goals are what's important. And our first goal is going to be to review eliminating fractions and reviewing the Gaussian Elimination method. Our second goal is to combine the concepts in the first goal. So let's just go ahead and get through the first goal here real quick, and hopefully you'll see what I'm talking about when we move on to the second goal. So to eliminate a fraction, multiply every term in the equation by the denominator. So I have an equation that has a fraction. I want to eliminate that fraction. And so I'm going to eliminate that fraction by multiplying everybody by 3. Remember, it either multiplies or it cancels. It can't do both. So every term gets a 3. That's a term. This is a term. And this is a term. 3 times y doesn't cancel, so it must multiply. So now I'm left with 3y. 3 times 4 over 3. These 3's cancel. And now I'm left with just 4x. Nothing to cancel, so they must multiply. And I'm left with 15. 5 times 3 is 15. I wanted to review that because it's important to know that you can change the way an equation looks. That's so important that I'm going to write it down, and you need to write it down in your notes. Bad N. It's so important that we know this. Okay. Oh, email. All right. So that was the first part of the first goal. The second part of the first goal is to solve using the Gaussian method. Remember, Gauss showed us that you could add equations together. 9-year-old Gauss. So here I have 2 equations. I'm going to add them together. Positive x minus x. These guys are going to cancel each other out. There are no more x's. Minus y plus 2y, I owe 1, I have 2, that means that I have 1y. Owe 2, I have 6, that means that I have 4. Divide out the 1, and y equals to 4. I want to point something out that's very important for the next goal. A variable canceled out. That is so important. Please note that in your notes. Notice that a variable canceled out. Sometimes the x's cancel, sometimes the y's cancel, but somebody cancels. Remember, we use this 4 to find we use this y to find our x. I like the first equation, so I'm going to say x minus, and I'm going to put a parentheses, equals -2. Inside the parentheses, I put a 4. And now we have the equation x minus 4 equals -2. And I have my 6 steps to solve. And to be honest, I only have to use my last step on this one because there's no fractions. I can't distribute. I can't combine like terms on each side of the equal sign. All the x's are on one side. Oh, I'm sorry, I can't do steps. I can only do step 5. I can add or subtract away a number from the variable side of the equation. Calm down, it's going too fast. So here, x equals, I have 4, I owe 2, that means I have 2 remaining. X equals 2, y equals 4. I now know where my lines cross at. They cross at 2, 4. I wanted to go through this problem, review this problem with you guys, because in the next example, we're going to have to use a combination of these ideas in order to make a variable cancel out. And that, before I end, I want to add this. Hopefully we're starting to realize that in mathematics, we're combining ideas. And when we combine ideas, we can make new problems. And in that sense, mathematics is very artistic, where you can add or combine ideas together. And when you combine ideas together, you get a new idea. So you'll see how this ties together. I'm gonna go ahead and erase everything and set up the board for goal 2. So I'll be back. I'm back. All right, so let's move on to our second goal here, and that's combine the concepts in the first goal. So I want to talk about, for a minute, strategic thought, because that's what this lesson actually turns into. Strategic thought. And I thought that I would explain strategic thought as the ability to plan ahead to get the desired result. And often in life, we call this playing chess. And what that means when you're playing chess is you're playing a couple moves ahead. So to use the pandemic as an example of people playing chess, when it became obvious that we were going to be locked down and things were not going to return to normal, people that have this ability financially started thinking, what could I invest in that is going to be more needed during a pandemic, a lockdown? What could I put my money into so that it makes money off of the pandemic, which is not a very, I don't know, I don't want to give my thought on that, but that type of person is recognizing what situation they're in, and they have a desired result. They want to earn more money, and so they focus their investments on things that they know are going to be businesses that are going to have more revenue in these times. So, like, for example, Amazon, everything's getting delivered. Zoom, everybody's on Zoom. Internet companies probably, FedEx, UPS, these are companies whose businesses have probably gone up, and people that recognize, like, we're playing chess, recognize what's probably going to be profitable during this time. They were playing chess when it came to financial moves during this pandemic. For us in this lesson, and this is good practice, I mean, it really is important in life to play chess. You want to live life thinking a couple moves ahead. You don't want to move around and hope that you end up in a mansion one day, because it's not going to happen. You want to be able to move your way around life and put yourself in a position to get a desired result. That's playing chess. And mathematics really does help you practice that. I think it's really good in that respect, and I've used it in my personal life a lot. If we have time, I'll share some of the times in my life that I've used strategic thought to put myself in better positions. Anyways, our desired result using strategic thought is in this lesson is to get a variable to cancel using both ideas in the first goal. Remember, that's what's happening when we're using Gaussian elimination correctly. A variable will cancel when we add them together. Now, if they don't cancel, we can figure out how to make them cancel, and that's going to be a combination of these two items from our first goal. So I have 2 examples, and I hope that we're going to look at these problems before we start doing them. Because if we start doing them without looking at them and trying to be strategic with them, we're going through the problems like this and hoping that they work out. So I'll do the problem like this, and we'll see what happens, and then I'll take a step back and explain why we needed strategic thought. So I'm just going to add these together like Gauss taught us to do. I owe you $3, I owe you $3, so I owe you $6. I owe you 3, I owe you 4, so I owe you 7. And I get 14. Nobody canceled. That's a problem. That's a problem. We did the Gaussian elimination, but we didn't use the skill set that we used to eliminate fractions. So what I want to point out is, when we eliminate fractions, that shows us that we're allowed to change the way an equation looks. We're allowed to change the way it looks. And the way these 2 equations look right now, nobody is canceling. So we're allowed to use multiplication to make one of the equations look differently so that somebody will cancel. So strategically, I have a better chance of getting the x's to cancel than I do the y's. And I know that I have a better chance because these numbers are very close to canceling, with the exception that they both have the same sign. So in order for me to get them to cancel, I'm just going to multiply everybody by -1. And when I multiply everybody by -1, what that's going to do is it's going to change the sign of this. So -1 times a -3x, that gets me a positive 3x. And a -1 times a positive 3y, that gets me, or -1 times a -3y, that gets me a positive 3y. And a -1 times a 6, that gets me a -6. See, if we would have taken a second to look at the problem before we just started working on it, we would have realized that in its current form it would have canceled, and we would have had to be strategic with our thought and figure out what we had to do to one of the equations so that when we used Gaussian's elimination, we would get a variable to cancel. So now I'm going to be able to get my x's to cancel. Right? So now I can add, now I can add these two equations together, and -3x plus 3x, that goes away. I owe you 4, I give you 3, I still owe you 1. I have 8, I owe 6, that means I have 2, right? And we go about solving this exactly how we did before. Except now, we have to play chess a little bit. We have to understand what we have. So if I look at this next problem, before I do any work, I know that no one's going to cancel here. I know that no one's going to cancel there. No one's going to cancel out. So if I was to add these together, I would get -2x minus 3y. No one canceled. I did not get my desired result for the lesson. However, if I take a step back and I look at this, is there any way I can make these numbers the same? I could, but it'll take a little work. Is there any way that I can get these numbers, is there any way I can get these numbers to cancel by multiplying one equation? It's kind of messy, so I'm not going to try. Is there any way I can multiply one of these equations by a number so that these guys cancel out? And this is a lot easier. I know that I can turn a 3 into a 6, which will make that guy go away. So again, I'm trying to play a move ahead. I'm playing chess. And this takes a little practice, right? You wanna be able to take a step back and look and get a result. Because if you just start doing without a direction, you might make things worse than they were to begin with. So I recognize that I can make this into a number that'll make this go away. So I'm going to multiply everybody by 2. So you get a 2, you get a 2, and you get a 2. That's why I've reviewed eliminating fractions, to show you that you can multiply every number or everyone in an equation by a number and change the equation. It'll change the way the equation looks. So now what I'm going to get is I'm going to get 2 times -5 is -10x. 2 times positive 3y is 6y. And 2 times -12 is -24. I owe 10, I have 3, so I owe 7. Minus 6y plus 6y, that cancels. I have 3, I owe 24, that means I owe 21. I got somebody to cancel. I got my desired result for this lesson, that's to get a variable to cancel. Let me clarify a couple things. In these examples that I did, I multiplied the top equation. You don't always have to multiply the top equation. Maybe you multiply the bottom equation. But the point is, we're going to have to multiply one of the equations by a number so we can get Gaussian elimination. So let me write that out and make this clear. The point of this lesson is we have to multiply one equation by a number so we can cancel a variable. Look, exciting writing, right? The point of this lesson is we have to multiply one equation So again, mathematics becomes very artistic in the fact that we can combine ideas and create new types of problems. You know, so you're seeing in front of you new ideas, new problems being developed by combining two ideas. So hopefully this makes sense. I'm going to go ahead and end the lesson here. We're going to probably have to spend a little time discussing and practicing, but you know, strategic thought is an important skill, and I really think that these lessons help you develop this very important life skill. So I'm going to go ahead and end it here. Again, I hope everybody is doing all right out there. Have a good day, everybody. Bye-bye.